Hey, Year 10! How's it going, guys? It's been nice to see you guys all on the chat and have you all here. Sean, hey, Sean. We are missing a good few number of people. No. Sorry, I'm trying to... yes, set Toby's on fire. I know, right? I know. So hoping by the end of the term to set Toby on fire, and now I feel like I've missed it. Missed my chance. Still missing loads of people. Missing Harris. Missing Nick. Missing Ashley. Missing Anna. Missing Toby, Ben, Tong, Andy. Missing loads of people. There's Ashley. Hey, and Anna. Yeah. Great job. Nick and Harris. Anyone seen Nick and Harris? And then Toby, Ben, Tong, and Andy. Toby's in. I have arisen. I like it. It should have been I have arisen. Arisen would have been better. Hey, Toby. There we go. Clocked you in. Anyone else? Anybody else? I need Tong, Ben, Andy, Nick, Harris. Come on, Year 10. Come on. How have people got on with... That's better. It's better. Yeah, there's Harris. Yo, Harris. Sup, dude? Sup? So how many of you guys have handed in your homework, huh? Punks. Okay, I have had 8 people turn in their homework, 12 people not. Oh, Year 10. Oh, hey, Tom. Question 10 was so hard, I know, right? Oops, I'll hand it in now. Cool. I have, handing in now. Good job. Go. Go. Good job. Nice to see you, Tom. Hi, Tom. It's nice to see you. I always forget that I'm on camera. It must be really weird, you guys just watching me, because I'm kind of like swapping between this laptop and this laptop. Hello. Must be really weird. Hi, Tom. Yeah. Oh, I miss you guys. I want to go back to school. Okay, so are we going to accept the missing people? There are 3 people missing: Nick, Ben, and Andy. Tong. Oh, we do too, sir. Oh. Of course you're my best chem class, obviously. Obvs, Ashley. Tong, can you message Ben? Thank you. And I know that it doesn't, yeah. Thank you. Oh, I do miss you guys. Okay, right. I will accept the missing people. I will mark then as absent. He's on his way. Yo, Ben! Here we go. Just Andy and Nick now missing. Thanks, Tom. Really appreciate that. I don't know what you should. His message is below. Harris. Oh, hi, Nick. Sorry, I'm late. Yo, Nick. Nick's in. Andy. Just Andy to go. Andy is here. Oh, good. Good to see you, Andy. Thanks for coming. Right. Okay, folks. On to chemistry. So the first thing we're going to do, we're going to go through the homework. I know that. I'm just going to check how many people have handed in. How many people have handed in now? Still 8. Oh, 10. 10 people have, 10 people haven't. Oh, come on, Year 10. Come on. I really wanted to have everyone's homework in. Okay, it's fine. Sorry, I'm still submitting. It's okay. Okay, right, let's crack on. So I will share my screen. Share. Sometimes I just get lost chatting with you guys. Oh, I really miss you. I think I'm getting a bit of like extreme cabin fever now. I just feel like I just want to be back at school, hanging out with you guys. Oh, it's sad. Right, okay. So, guys, I know question 10 was hard, by the way. it was really lovely. Ashley left me a lovely message saying, I'm going to do this. I thought it was brilliant, Ashley. It was my favorite message of the day. Thanks so much. It proper made me smile. Right, so we're going to run through the answers, and then I'm going to jump into the next section. Okay, so calculate the mass. I need my calculator on standby. Calculate the mass of aluminium that can be formed from 1,000. So I've got 1,020 grams of aluminium oxide, and I'm looking for the mass of aluminium. Right, step one, get to moles. Get to moles. So we've got number of moles is grams over rams. Right, so I've got 1,020 over. I now need the relative atomic mass of aluminium oxide. So aluminium is 27, and there's 2 of them. I'm going to add that to oxygen, which is 16 times 3. And I'm going to get a relative formula mass, because it's ionic, of I have no idea. 27 plus 27 plus 16 plus 16 plus 16. I get a relative formula mass of 102. So I go, oh, look at that. Isn't that clever? I don't even need to do that. That's 10 moles. Cool. Next, now that I've got to moles, step 2, use the ratio. So the ratio is all the way through is a 2 to 4 to 3, but the only one I'm really needing is that one. So the ratio is 2 to 4. There's a mark for writing that down, and I'm going in that direction. So that's going to be a times by 2. So my ratio is times by 2. So I'm going to take my 10, I'm going to multiply it by 2 to give me 20 moles. Right, 20 moles of aluminium. Step 3, get out of moles. Number of moles equals grams over rams. Reorganize. Multiply both sides by rams. Gives me, cross out, gives me number of moles times by rams, gives me grams. Never learn a rearrangement. Don't ever do it. 20 multiplied by, what's the relative atomic mass of aluminium is 27. We've already used the 4, just remember that. So 20 multiplied by 27, and I get 540 grams. Winner! Whoop, whoop. Tick it if you've got it. Boom! Next. I can even check that if you like, folks. Should we check that? I always love checking it, because if we split the equation like that, we've just got 540 grams. How much oxygen are we going to have? So we can actually make a prediction, can't we? We can make a prediction based on conservation of mass. So if I do 1,020 minus 540, 1,020 minus 540 gives me 480 grams left over. That should be the oxygen. Well, let's calculate that. That's a prediction. Yeah, a pred. Right, so, well, if I go back to the moles, I've got 20 moles of him. Look at the ratio. The ratio is a 4 to 3. How do I get from there? I divide by 4. That'll get me to 1, and then times by 3. So I'm going to take 20 moles. I'm going to divide by 4 times by 3, which is going to give me 15 moles. 15 moles of oxygen. Oxygen weighs 32. We get used to this after a while. Oxygen on the periodic table is 16, but oxygen, of course, is in a pair, so we're going to times it by 2. So oxygen weighs 32. At A level, 32.0. So 15 multiplied by 32, and I get 480 grams. Isn't that amazing? Smashed it! Oh, love it! I'm loving it. Cool. So that 500, that is absolutely 110% correct. Yeah, that's right. I said 110%. Right. Next equation. Calculate the mass of oxygen, question mark, from 10 grams of calcium. Okay. 10 grams of calcium. Right. So step 1, get to moles. Number of moles equals grams of rams. So I've got 10 grams over the relative atomic mass, and the calcium weighs 40. So I'm going to have, that's 0.25, right? Something like that. 10 divided by 40 gives me 0.25 moles. Step number 2 is use the ratio. You've got to roll your R whenever you say the word ratio, folks, just so if you want to practice yourselves, you know, more than welcome. Ratio. Yeah, you've got to really give it some good oomph on the roll of the R. Yeah, it's a bit Italiano, ratio. Yeah, so the ratio, which was a 2 to 1 is what I want. So that my ratio is 2 to 1. I'm going in this direction, so I'm going to divide by 2. So I'm going to take 0.25, I'm going to divide by 2, which will give me 0.125, I believe. Divide by 2, check, yep, indeed. So that's many moles of oxygen. Moles of oxygen, Spanish, if you're wondering. So now I need to step 3, get out of moles. Well, number of moles equals grams over rams, but I want rams. I'm going to multiply both sides by rams to get rid of rams from the right-hand side. So I'm going to do moles, 0.125 multiplied by oxygen. Now, oxygen, of course, was 32. We're getting used to this now. Multiplied by 32, and I get 4. The answer is 4 grams. If it's 3 sig fig, it'd be 4.00 grams. What did the questions say? I didn't say anything. So 4 grams, I'll accept. Absolutely. 3 sig fig, of course, always useful. Right, next. What mass of propane, so 48 grams of oxygen, what mass of propane could be burnt? Right, step 1, get to moles. Number of moles equals grams over rams. So we've got 48 over, what did oxygen weigh again? Weighed 32, didn't it? 32.0 at A level. Then 48 divided by 32 is 1.5. 1.5 moles. Right, ratio, step 2. Ratio. The ratio is going to be, whoa, it's a 1 to 5. It's a 1 to 5 ratio, but I'm going in that direction. That's tricky. Going to divide by 5. So 1.5 divided by 5. 1.5 divided by 5 gives me 0.3. I'm going to make that bigger. 0.3 moles. Step number 3, get out of moles. So number of moles times by rams gives me grams. So I've got 0.3 multiplied by what's the relative molecular mass of propane? Well, carbon is 12 and there's 3 of them. And I'm going to add that to hydrogen, which is 1 times by 8. Total is 44 at A level 44.0. 0.3 times by 44 is 13.2 grams. 13.2 grams, and that is 3 significant figures. Tick it if you've got it. Boom! Next. Okay, ammonia. So what mass of ammonia can be made from 20 grams of hydrogen? Right. Step 1, get to moles. Number of moles is grams over rams. Agreed? Next, so put in my numbers, 20 grams over. What does hydrogen weigh? Well, hydrogen on the periodic table is 1, but it's in a pair, so it weighs 2. So over 2 gives me 10. 20 divided by 2 is 10, absolutely. Yeah, that's all right, 10 moles. Yeah, 10 moles of hydrogen. Step number 2, use the ratio. Ratio is, it's a 3 to 2. Yuck. 3 to 2. So to get from there, I need to get that to 1, which is divide by 3, and then up to there, which is times by 2. So I'm going to take 10 moles. I'm going to divide it by 3. So 10 divided by 3 gives me 3.333. And then I'm going to multiply it by 2, and then times by 2. And I'm going to get 6.67 moles of ammonia. Right, step number 3, get out of moles. Yeah, so number of moles equals grams over rams. And then need to reorganize times both sides by rams, makes rams disappear. So number of moles times by rams. What does ammonia weigh? Yeah, equals grams. So I'm going to go, I've got 6.67 multiplied by ammonia. Ammonia is nitrogen is 14. And then plus hydrogen, which is 1 times 3, which is 17. Multiply that by 17. I've kept that number on my calculator, folks. And I get 113.3 grams. And I'm done. Whoop, whoop. 113, 3 significant figure if you prefer. Winner. Next. Right. Okay. Next. I have got what mass of sodium hydroxide, so there's my question mark, is needed to know. Whoa, that is a lot of sulfuric acid. Holy moly. Holy moles. It's gonna be holy moles. Right. Whatever. So, step 1, get to moles. Number of moles, it's grams of rams. So I've got whoa, but the problem is I'm in kilograms. So I'm going to have 24.5 kg. Multiply that by 1,000 is going to give me 24,500 grams. Holy guacamole. Hummus. Whose side? Thanks, Shan. Ugh. Sign at you. I'm ughing. Ugh. Whatever. Hummus. Yeah. Grams over rams. So I've got 24,500 divided by, what does sulfuric acid weigh? Sulfuric acid, hydrogen is 1 and there's 2 of them in it, so times 2. I'm going to add that to sulfur, which is 32 times by 1. And I'm then going to do plus that to oxygen, which is 16 times 4. Total is, I have no idea. 2 plus 32 plus 16 times 4. 98.0 at A level, 98 at GCSE, so over 98. 24,500. Checking my calculator was all right, that. Over 98 gives me 250 moles. Holy moly. Let's get rid of that. Right. In step 2, use the ratio. Yeah, and the ratio is a 1 to 2, and I'm going in that direction. So this is a times by 2. So I'm going to take 250 and multiply it by 2, which gives me 500 moles. Wow, that's a lot of moles of the sodium hydroxide. Holy moly. So I've got 500 moles. Step 3, get out of moles. Number of moles equals grams over rams. Reorganize times both sides by grams. Gives me grams. So I'm going to take 500 and I'm going to multiply that by what's the weight of sodium hydroxide? Well, sodium is 23 plus oxygen, which is 16, plus hydrogen, which is 1, which I think gives me 40. I think that's right. Yep, times by 40. So 500 times by 40, and I get, whoa, 20,000 grams, or 20 kgs. And I'm done. Whoop, whoop. Next, that was a hard one, that. Whew, that was tiring. Next, what mass of carbon dioxide is formed when 7.41 grams, I should zoom in on this really, there we go. 7.4 grams is decomposed completely. Okay, step 1, get to moles. Number of moles is grams over rams. So I've got 7.41 grams divided by, what is the MR of copper carbonate? I think it's 123.5. Copper, let's check that. Copper is 63.5 plus carbon, which is 12, plus oxygen, which is 16 times 3. 63.5 plus 12 plus 16 times 3 gives me 123.5. Winner. I got some of those in my head, folks. Sorry about that. It's just me being a nerd. Yeah. Mr. D, if the question gives the mass in kilograms, do you put the answer in kilograms or grams? Shan, it depends on the question. I would personally just spit it out in kilos. Because 20,000 grams is such a ridiculous number. I just go for 20 kilos. Yeah, if they give me it in kilos, I'll spit it out in kilos. Yeah, definitely. If they give me it in tons, I'll spit it out in tons. Yeah, I'll just flip it back at the end. Right, 7.41 divided by 123.5 gives me 0.06. 0.06 moles. What's the ratio? The ratio... Oh, look at that. Isn't that lovely? The ratio, which my thing is not having it. Yeah, the ratio is a 1-to-1. Oh, that's nice. I'm still going to write it down, mind. Yeah, it's so easy not to. Commonly lost mark at GCSE there. Step 2 is you get a mark for writing this down. It's a 1-to-1. Yeah, therefore, moles of CO2 equals 0.06 moles. Yeah. Right, step 3, get out of moles. Number of moles times by rams gives me grams. So number of moles is 0.06 multiplied by CO2, which is 44. 12 plus 16 plus 16 is 44. Multiply that by 44, and I get 2.64 grams. And I'm done. Tick it if you've got it, folks. Next, doing well here. What mass of carbon monoxide is needed to react with, year 10, make me proud. Why is that name wrong? Why is that name wrong, folks? Let's see what people say. Why is that name wrong? Oh, come on, year 10. It doesn't say iron 3. Ashley, you are just a hero. Well done. You're such a star. Ruby, think about the number. That iron there, think about Ashley is the, or 3. Yes. And in fact, that one's 3. What Ashley said. That's really funny. Iron 3 oxide. Well done, year 10. Oh, yeah, that was so confusing. Yeah, they just haven't named it right, folks. You know, even the internet is a great resource for chemistry, but they don't half give you some rubbish chemistry sometimes. Yeah, means 3. Nah. I just typed fast. Honestly, Ashley, it was great. Well done. So you're right. That there should have been called iron 3 oxide. Yeah, they're just being lazy. That's rust. Yep, I like it. So what we now need to do is step 1. Yeah, get to moles. So I've got number of moles is gram. Do you notice, year 10, that I've been doing this 15 years and I write down this equation every time? Yeah, I'm doing it because it's about reinforcing good chemistry. And it's always about making that solidify in you, because once those things kind of solidify in your mind, all of a sudden the fog that is the chemistry understanding just kind of fades away, because you kind of start knowing the bits that you're doing. So I've got, first thing I need to do is 2.08 kilograms. I'm going to multiply that by 1,000 to give me 2,080 grams. Now I can do grams over rams, 2,080 over the relative formula mass, because it's ionic. Yeah, so we've got 56 times by iron is 56 times by 2. I'm going to add that to oxygen at 16 times 3. And I get a number that I have got no idea about. 56 times 2 plus 16 times 3. Calculator's gone mad. Gives me 160. There we go. So 2,080 divided by 160 gives me 13 moles. But can I just say, by the way, at that point, it always tells me that I'm on the right line. I'm on the right line because it's given me a whole number. The chances of that are so small. Like in reality, if you're going to measure out a random mass, you're never going to get an exact whole number like that. Right, what's the ratio? Step 2, ratio. I'm becoming more, do you ever notice that I'm sounding a bit more like Mario each time? A ratio. Yeah, some kind of Italian, I don't know what's going on, like Mario from the computer games. Or wow, ratio. So we've got, the ratio is a 1 to 3, because that's what I'm after. Ratio is 1 to 3, there's the mark, but I'm going in that direction, so it's a times by 3. So 13 multiplied by 3 gives me 39 moles. 39 moles, 39 moles of carbon monoxide. And now step number 3, get out of moles. Yeah, number of moles, grams over rams. I'm going to reorganize times by rams, move rams over there. Yeah, so I need to do 39 multiplied by, how much does carbon monoxide weigh? Well, carbon is 12. Yeah, carbon is 12, and I've got one of them. I'm going to add that to oxygen, which is one of them, 16. So that's going to be 28. Yeah, so I multiply that by 28. I'm going to get 39 multiplied by 28. And I'm going to get 1,092 grams, or otherwise known as 1.092 kilograms. Thank you. Winner. Next. Okay, so what mass of chlorine reacts with 20 grams of iron to form iron? Oh, now they do it. Now they give the 3. Yeah, just talk about inconsistent, guys. It just, humans are fallible, even chemists. I know that you guys see us teachers as like we're machines that never make mistakes, but we do. I mean, I do it on a regular basis. Every time I speak in Italian, I think I'm wrong. Although I'm not 100%, I think my Italian's pretty good. Ratio. What do you think? Give me some feedback. I think my Italian's pretty good, right? Anyway, so step 1, get to moles. So number of moles equals grams over grams. And I've got 20 grams. And what does iron weigh? Well, iron weighs 56, 55.8 on a brilliant. Thanks, Jan. No comment. Ruby. It's really upset me, Ruby. It's really upset me. It's 0.357 moles. Yeah, Christmas moles. I might. Oh my God! I think I may draw a Christmas mole next. I might do that. Although I am starting my. I'm going to do a reacting mole. It's going to be amazing. It's going to be amazing. So I've got my moles. What's my ratio? Step 2, ratio. My ratio is a 2 to 3, and I'm going in that direction. So this is a divide by 2 times by 3 malarkey. So I'm going to take that number. I'm going to divide it by 0.357. I've actually got it on my calculator. I'm going to divide it by 2, and then I'm going to times it by 3. And that's going to give me, so divide by 2 times by 3 gives me 0.536 moles of chlorine gas. Winner. Next, step number 3. Get out of moles. Number of moles times by rams gives me grams. So I've got 0.536. I've actually got it on my calculator. What's the MR of chlorine? Well, chlorine is 35.5, but it's in a pair. So times by 2, 71. Multiply that by 71. 71, and I get 38.0 grams. Boom! Yeah. Easter mole. Oh my God! Victoria, you are absolutely right. I'll do an Easter mole. I'm on it. Oh, that's quite exciting, that. You know, if somebody accidentally clicks on these videos, I wonder what they think. Mr. Duncan, you can draw a mole in a basket of Easter eggs. I can so do that, Chad. With rabbit ears. Can, definitely. With a mask. No, I'm not giving it a mask. Then it's not going to look like a mole. And at home, a mask. I know, right, Shan? Go figure. Crazy. Right, next. Ooh, hydrazine. Hydrazine is really dangerous. It's a rocket fuel. Yeah, it's in the Martian. It's in the Martian. I know, gone Yorkshire. So hydrazine it can be made by reacting ammonia, hydrogen peroxide. What mass of ammonia? Question mark. It's needed to make 148 grams of hydrazine. Okay, step number 1. Step 1, get to moles. Moles. Yeah, grams over grams. Yeah, and we've got 148 grams over. What does hydrazine weigh? So hydrazine is nitrogen, which is 14 times by 2, added to hydrogen, which is 1 times by 4. I have no idea what that is. 14 times 2 plus 4. 32. 32.0 at A-level. Potato! Oh, I don't know why I said that. Roo, why did you write potato? Potato, I know, right? Over 32 gives me 148 divided by 32. 148 divided by 32 is 4.625 moles of hydrazine. Right, step number 2, use the ratio. So the ratio is, I'm going to zoom in on this one. Woo, hello. So I'm just going to make this a bit clearer for people. Yeah, let's clear all this up, get rid of all that junk. So the ratio for these guys is a 2 and a 1. So it's a 1 to 2, but we're going in that direction. So the ratio is 1 to 2. No, 2 to 1, and then I'm just going to write the arrow. 2 to 1 going in that direction. So this is a times 2. I like it. So it's changed back to black. So I've now got, where's my moles? There it is. So I get 4.625 times by 2 gives me, so times that by 2 gives me 9.25 moles of ammonia. Right, now I need to get out of step 3, get out of moles. The Martian, yes, let it go. Step 3, number of moles times rams gives me grams. Yeah, I never learned that. I'm rearranging it in my head. Sorry if I did it too quick. 9.25 multiplied by the weight of ammonia. How much does ammonia weigh? So ammonia is, nitrogen is 14 times 1, and I'm going to add that to hydrogen times by 3, 17. So I'm going to multiply that by 17, gives me, times by 17, gives me 157, technically 3 sig fig, grams. Nice. Right, hardest question, folks. This one here, this is where it's at. This is the real stuff, this is. By the way, I don't want anyone to worry about this question. I'm going to be teaching you, I'm going to be giving you a lesson. These are called, these particular questions are given a topic. It should have been in my list at the beginning of the topic when I said calculations and I gave you that list. These are called water of crystallization questions, and EdXL loves these guys. And they are, by the way, just to put this on a level, this is a Love 8/9. Yeah, these are hard water crystallizations. Yep, that's the one. Oh, is it 1L? I didn't do that, Sean. Yeah. Is it a 1L, is it? It's not like I've been writing down that word for years or anything. Next. Right. So let's take this question one bit at a time. So what we need to do is, no, I spelt it wrong. I knew I'd got it. Jan. Oh, I love you guys. Right. So let's extract the data. 10 grams of the hydrated salt. Right, let's label that. That's this guy. So this guy, I have got 10 grams of. And it has an unknown number of water molecules bound to it. Yeah, this here, this X, I'm going to make that thinner. This X here literally says unknown. Yeah, but what we know is that we have a solid salt crystal, and trapped inside the salt are an unknown number of water molecules. Yeah, we don't know how many there are. So we're trying to figure that out. And by the way, it's all about counting particles. So the first step in this particular process, this question, is that it says I got 10 grams of it. And then he heats it up. He decomposes it to form that many grams of the anhydrous. So let's put that on here. I'm going to color code this, folks. Color code it as best I can. So this bit here, which is the anhydrous without water, is 4.40 grams. Right. I can now do my first bit and get my first mark. So water equals 10 grams, which is all of this bit, minus all of this bit. And I'll get the amount of water I've lost. So I'm going to do 10 grams minus 4.4 grams, and I get 5.6 grams of H2O. Right, 1 mark right there. Next, now that we've got to that, what we now need to do is we need to count particles. Yeah, so let's go to moles. Moles. So we need the number of moles of this guy and the number of moles of this guy. We need the moles of the water and the moles of the anhydrous. So let's just write those down. Sodium sulfate and water. Right. So the first thing is we know grams. The grams of this is 4.4 grams. And the grams of water is 5.6. Chemists don't work in grams. What do we work in, year 10? Babe, don't give them the answer. What do we work in, year 10? What do we work in? Boom! Come on! Yes, Con! Con, you're my hero. Yeah, that's right. We don't work in grams. We work in moles. So, number of moles. Yeah, well done, Roo. I don't know. I love your capitalization. M, capital O, small l, capital E, small s. Love it. We work in moles. Moles allows us to count particles. So number of moles is grams over rams. So what the heck does that weigh? So we need to weigh this now. Sodium is 23, and I've got 2 of them. And then I've got, add that to sulfur, which is 32. And then I'm going to add that to oxygen, which is 16, and I've got 4 of them. I have no idea what sodium sulfate weighs. Haven't got a clue. Plus 23 plus 23 plus 32 plus 16 times 4 gives me 142. There we go. Get rid of that now. So I got 142. Ashley, great job. Ruby, well done. Kieran types moles. So we've got moles equals 4.4 divided by answer gives me 0.030. Oh, gets rounded up. There we go. That's how many moles I've got of that guy. How many moles of water do I have? I've got grams over rams. What does water weigh? Everyone should know this by now. What does water weigh? What does oxygen weigh? You know, these are numbers we need to know. Yeah, let's see who gets it first. What does water weigh? Should be like that. Boom. Type on the calculator. Boom. Thank you very much. Well done, Tom. Well done, Rue. Well done, Toby. Shan. Ruby smashed it. Well done. Weighs 18. At A level, 18.0. Yes, Con. Well done. You guys are nailing this. 5.6 divided by 18. I've had way too much coffee. 5.6 divided by 18. 0.311. Yeah. Right. We have now counted particles. I think your chat is lagging. We replied very quickly. It's all right. My chat probably is lagging. Yeah. It's probably lacking a bit too. See what lagging. So, okay, guys. So look what we've now just got. This is important. This is a big step. So we have just worked out this. We have 0.0310 moles of this guy. Yeah, that's what we've just worked out. And we've just worked out that we've got 0.311 moles of water. Now, here's the leap of faith, year 10. Would everyone agree that in this formula, there is one of these guys, just one sodium sulfate, because there's an invisible one in front. Agreed? Well, what that means is I need to now get, and I know this is a massive leap of faith. It really is. I know. Guys, I need to get this number here to the number 1. I do that by dividing it by itself. If I divide it by itself, I get the number 1. If I now divide the other one by the same number, look what I get. 0.111 divided by 0.0310. I get 10.0. I get 10.0. It's really magic. It's proper magic, this, guys. Like, it really is. What's happened here is that I can work out what the whole numbers are. If I divide them all by the smallest, what will happen is I will make one of them 1. I know this is a massive leap of faith. Yeah, divide them all by the smallest. And I get 1 and 10. So my value of X is 10. Now, just to tell you, by the way, you can't have 10.03. That's impossible. You can't have 0.03 of a water. It just gets rounded to a whole number. Yeah, you can't have a fraction of a water molecule. So X is 10. Now, the next thing is, there is another thing that we could have done. Does everyone also agree? This is such a massive thing, this. Would everyone agree that we worked out the number of moles of both the water and the sodium sulfate? but the sodium sulfate moles were 0.0310. The moles of this guy, I know these get easier, I promise. This was 0.0310. Would you also agree that the ratio of this to this is a 1-to-1? It's a 1-to-1. What that means is this many moles is the total moles of that thing. And you've got grams. Number of moles. Let's try that again. Number of moles is grams over rams. Well, I've just worked out the number of moles. And the number of moles is, and I want rams, that's what I'm trying to find. The question says, calculate the formula mass and the value of X. Well, I worked out the value of X. You can now work out its formula mass. Reorganize, bring rams over there, equals grams. Now, I don't want that. I want rams. Bring the moles over there. Therefore, rams equals grams over moles. How many grams did I have originally? I had 10. I had 10 grams of the hydrated salt, and the number of moles was that. So if I do 10 divided by 0.0310, I get an answer of 322. And there's my relative. It's actually 0.6, but it doesn't matter. And that's the answer. If you wanted, you could have done it a different way. We worked out the formula mass over there, worked out the formula mass of the sulfate independently, yeah, of that guy. And we then worked out that there's 10 waters. Well, 10 times H2O. How much does H2O weigh? It weighs 18. We all know that now. That weighs 180. What happens if I add 180 to 142? 180 plus 142. I get 322. It's the same number. Isn't it magic? Guys, that brings us to the end of that worksheet. That was a long homework, that. I do understand if you guys weren't able to hand it in. Let's see how many people handed it in the end. Let's have a look. Whoop, 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 whoop. 10 people, I believe. 10 people handed it in. Yeah, 10. Oh, no, 13. Well done, guys. Well done. Well done, well done. Cool, 13 people. Well done, folks. I really appreciate that. Anyway, so now today's lesson is reacting mass part 2. I realize I've only got 10 minutes left. Well, I could do this in 10 minutes. That's the great thing. So, can everyone put a new title of reacting mass? And this will only take me 10 minutes, folks. In fact, 5. Reacting mass calcs, brackets, solutions. These are otherwise known as, I'm going to put this over here, these are otherwise known as titration calculations. It's what they're known as. They're given a rather special name. Titration calculations, but the process is the same. So the first thing for me to remind you is moles in solution is number of moles is concentration times by volume over 1,000 if I'm in centimeters cubed. Just a reminder. That's all I've got to do. The next thing is I give you a question. So, Mr. Duncan, Mr. D reacts. Mr. D reacts. I'm going to move that over to there. Sodium hydroxide with hydrochloric acid, with HCl. So HCl plus sodium hydroxide. They're going to give you the equation, which is nice. Salt and water. So Mr. D reacts sodium hydroxide with HCl. The vol of sodium hydroxide is 25 centimeters cubed. The concentration The concentration is unknown. Concentration is unknown. The HCl required to react was 18 centimeters cubed of 0.5 moles per dm cubed. Calculate concentration of sodium hydroxide. Now, I know that this, I hope you all realize, that people are reading this and going, oh my goodness, I feel completely lost in that. I don't want you to be lost in this. The process is the same. It's no different. Yeah, you're just doing the same thing we did before. We've got an equation. Sodium hydroxide plus HCl goes to salt and water. Now, I've given you an easy one because the ratio is 1:1. Yeah, let's put in my numbers. The sodium hydroxide, the vol of sodium hydroxide is 25. So let's put that in yellow. Yeah, so I've got 25 centimeters cubed of him. The concentration, so that's vol. The concentration is unknown. The hydrochloric acid, the HCl, was 18 centimeters cubed on volume, and its concentration was 0.5 moles per dm cubed. Right, find the question mark. Guys, notice the steps. Step 1, get to moles. That's it. We're using a different equation, folks. We haven't been given grams. Number of moles is C times V over 1,000, because I'm in centimeters cubed here. Right, C 0.5 times by volume 18 all over 1,000. 0.5 times by 18 all over 1,000 gives me 9 times 10 to the minus 3 moles. Next, step 2, use the ratio. The ratio is a 1:1. It's a 1:1 ratio. I get 1 mark in my exam for writing that down. Yeah, which means, because it's a 1:1, NaOH moles is 9 times 10 to the minus 3. It's the same number. That's awesome. Next, step 3, get out of moles. And what am I after? I am after concentration. Reorganize my equation. Number of moles times 1,000, bring that over, bring the vol down. Yeah, over vol gives me C. Let's input my numbers. 9 times 10 to the minus 3 times 1,000 over a volume. What was my volume of the sodium hydroxide? The volume of the sodium hydroxide was 25. Over 25 gives me times 1,000 divided by 25, and I get a concentration of 0.36 moles per dm cubed. Guys, this is not complicated. It is the same process, but with a different equation. That brings me to the end of my lesson. I will submit the homework. See if I can find my way back to, where am I? That one. Hello! We're done. We're done. Oh, guys, it's been a tough lesson, I know. But guys, can I say how proud I am of you guys? You're doing so well. Please keep up the hard work. I promise you, the time spent doing these homeworks really makes a difference. It really does. And I miss you guys. I can't wait to go back to school. I hope you guys have a lovely rest of your day. I will post on the classroom your homework. Yeah, it will be on literally in 2 minutes, and I will post it. It's nice to see that I've nearly got everyone's homework in, which is great. But guys, it really has been so nice to see you guys. I really miss you guys. Take care of yourselves. Be safe. I'll see you tomorrow for our last lesson before Easter. When we get back to school, we should do more practicals. I completely agree, Toby. Yeah, like I said earlier in the chat, I've got every intention of setting fire to you. Yeah, I really can't dig myself out of that one. But guys, take care. Be safe. I'll post it on the chat, on the classroom right now. I'd love you just to have a go straight away. But otherwise, have a great rest of your day, folks. I miss you loads. Take care.